Today we're going to be talking about velocity time graphs, and let's go ahead get started. I want to start out by telling you a little story, or maybe reminding you of a story that happened a couple of years ago. It was October of 2018. There were these new, really nice planes called the Boeing 737 MAX 8s, and there was a crash in India, a Lion Air crash, and over 100 people died in it. And then just a couple months later, there was a crash of the same type of plane in Ethiopia. This was the Ethiopian Air crash in March 2019. And there was a mystery of what caused these crashes. A total of nearly 400 people died between these two wrecks. And there was this big clamor, understandably, of course, and there was this big need by everyone to understand why these crashes occurred to feel safe on planes again. And so the black boxes were recovered, and the data from those black boxes, which of course records all the sensor data from the planes, was graphed out here in terms of the vertical speed. So we have vertical speed graph over time. And our question is, what can we learn from this? What does it mean? So here we have the Lion Air flight, and for this period here, it was moving at a constant upward speed, or relatively constant upward speed, of 1,500 feet per minute. So for this time, it was going upward at 1,500 meters per second, or feet per minute, excuse me. Then we have this period. This period is where it goes from upward at 1,500 feet per minute, to downward at more than 1,500 feet per minute. It was going up, and then it started to come down. In other words, the plane did this, right? It was going up and then coming down. Then the plane started to go up again. This is where it went from negative 1,500 feet per minute to, it's probably around 600 feet per minute. This doesn't mean it went This doesn't mean it went up. This means it stopped going down and started to go up, right? It's the velocity that's changing. It's going from a negative velocity to a slightly positive velocity. Then the next period, it goes from positive to velocity to negative velocity again, meaning it was going up and then started to go down, started to go up again, started to go down again, started to go up again, down, up, down, up, down. What was happening to the plane? It really looks like the plane was alternating between climbing and descending, climb, descend, climb, descend. The same thing happened here with this Ethiopian Airlines flight. We see climbing, and then less climbing, and more climbing, and less climbing, down to descending slightly, and more climbing, and then descending, and then climb, descend, climb, right? Because wherever this dot is, that's what the speed is doing. And so again, we see this alternating pattern. And what it ended up being was a computerized system that was meant to make the plane easier to fly, that was overcompensating when pilots tried to pull the nose of the plane up. So what happened is, as the pilots were pulling up, the plane's system would push the nose back down, and they would try to fight it by pulling it up again, and the plane would push its own nose back down. And this system that was designed to make the plane easier to fly is actually what made it very dangerous and caused these crashes. But we're here to look at velocity time graphs. And we can hopefully see now what kind of information can be gathered from them. So the first thing we need to remember about velocity time graphs is that we are graphing velocity. We are actually putting velocity on the graph. So, how did I find this point? All I did was I calculated the velocity for the object at this point, and I made a mark at 0 seconds and 40 meters per second. I'm going to assume that this is meters per second, and that these are seconds. At 1 second, if the object was still going at 40 meters a second, this is very fast. If it's still going 40 meters per second, we'll put another dot right at 40 meters a second. At 2 seconds, another dot, same speed. 3, same speed, same velocity. 4, same speed, same velocity. And so what do we end up with? A horizontal line, which must mean that the object is maintaining a velocity. It continues to move at the same velocity or the same speed, although here we have a positive direction, so I would say velocity would be a better term. Here, the velocity is increasing over time. As time goes by, this velocity gets higher and higher and higher. Well, what's the word for that? Acceleration. We can actually calculate the acceleration by getting the slope of this line. So acceleration would equal the change in velocity over the change in time. And guess what? Our vertical axis is velocity, so this would be v2 minus v1 divided by t2 minus t1. And that's exactly what acceleration is. And here we have an example of negative acceleration. And I want to run through this graph for you so you see the whole thing. This is negative acceleration because the velocity is decreasing over time. We started fast and we got slower and slower and slower as time went on until we came to a stop. But then what happened? The object got faster and faster and faster in the negative direction. This is a constant negative acceleration because the slope of this line is acceleration and the slope is constantly negative. So, in terms of what happened, the object started fast, slowed down, stopped, and then started speeding up in the other direction. This is a constant negative acceleration. Now let's do a little bit of practice, make sure we understand what's going on at each point. So we have 4 regions here, A, B, C, and D. And I might ask you something like, what is happening in region A? Well, the speed started from 0, and 10 seconds later, it's at 15 meters per second. So the object in region A is accelerating. Well, how much is it accelerating? Let's do rise over run. Rise over run. Let's get the slope. So the rise here is 15, and the run is 0 to 10 is 10. And 15 divided by 10 is 3 halves, which is 1.5 meters per second per second. So the velocity at region A is, or I'm sorry, the acceleration at region A is 1.5 meters per second per second. All right, let's look at region B. In region B, the speed starts at 15 meters a second, and 5 seconds later, it's still 15 meters per second, and 5 seconds after that, it's still 15 meters a second. What is the object doing? Well, it's moving at a constant 15 meters per second. And here we can say the acceleration is 0 because it's not moving at all. Let's make sure I label that. Acceleration A, acceleration B. It's not accelerating at all. It's maintaining a constant speed that whole time, a constant velocity that whole time. So there's no acceleration. In region C, we can see it's going from 15 meters a second to 25 meters a second. It's gotten 10 meters per second faster in a time of 10 seconds. So the acceleration in part C, in other words, it got faster, right? The acceleration in part C would be the rise, which is 25 minus 15, divided by the run, which is 30 minus 20. So that would give us 10 over 10, which is 1 meter per second per second. And then let's go to region D. In region D, the object is it returning to 0? No. It is returning to a speed of 0. It slows down from 25 meters a second to 0 meters per second in these 15 seconds. So let's get the slope here. The acceleration in part D is, what is the rise? Well, the rise, we end at 0. We started at 25, so that'd be negative 25. And what is the run? 50 minus 30. So the acceleration in part D is negative 25 over 20, which gives us negative 5/4, or negative, if you like decimals, negative 1.25 meters per second per second. And how can we tell it's negative? Well, one, we did the slope and it's negative. Two, the line is sloping down. So once again, to run through what's happening here, in part A, we have positive acceleration. The object goes from rest to 15 meters per second. Then in part B, it maintains a constant velocity at 15 meters per second. In part C, it speeds up further from 15 meters a second to 25 meters a second, accelerating at 1 meter per second squared. And then in part D, it slows down with an acceleration of negative 1.25 meters per second squared. Hopefully that's helpful. Let me know in the live session if you have any questions.